Hi, I'm Lorenzo di Carli, Assistant Professor in Computer Science. I'd like to begin my talk with a quote from the 2007 movie Michael Clayton. So George Clooney plays the titular character, Michael Clayton, who's a fixer, a lawyer that works at the boundary between what's legal and illegal. And in order to do so, he has to pretend to be different things about different people. And at some point, someone calls him out, and they tell him, you've got all those lawyers thinking that you're a cop, and you convince the cop that you are a lawyer. And I like to paraphrase this about myself, because, as I like to say, I convinced all the networking researchers that I'm a security expert, and all the security researchers that I'm some kind of networking expert. So, as you may infer from this presentation, my research is interdisciplinary within the boundary of computer science. Mostly I work at the intersection of networks and security. But my research also touches upon programming languages and software engineering. In fact, I had some PhD colleagues genuinely convinced that my PhD thesis was on programming languages, where it was not. I work on a number of projects, and some of the most relevant to this talk are probably my research on malware and on smart devices. So, in particular, ransomware. So ransomware, if you don't yet know what it is, it's a type of malicious software that installs on your computer, encrypts all your files, and asks you for a ransom in order to decrypt them and give them back to you. It's not just something that may end up on your laptop and encrypt your homework on your set of slides, but it can attack large organizations and create significant problems. Probably the most high-profile incidents to date is the attack against the government of the city of Atlanta last year. This attack took the city 3 months to recover, and recovery costs were in the neighborhood of $10 million. More recently, in July of this year, Johannesburg in South Africa was also subject of an attack. The city power utility was attacked, and customers were unable to pay their power bills, which caused blackouts. So this is a type of threat that creates significant problems in the real world. Recently, there has been a lot of buzz about using machine learning to detect and stop ransomware. So with this type of approach, then you train a machine learning classifier to identify the traits of ransomware and distinguish a ransomware process from benign applications, such as Office application and such. So part of my research investigates the robustness of machine learning as an approach to identify ransomware and stop it from installing. Unfortunately, we found that such approaches are still fragile. For example, when everything works well, you can use a machine learning classifier to distinguish you can feed benign and malicious process to a classifier. If everything works well, this classifier is going to identify your ransomware and tells you, well, there is something wrong here, you should not probably run this. But unfortunately, we found that with some minor transformation to a program, we can end up with new types of ransomware that still perform what they're designed to do. So they still encrypt files and ask you a ransom, but they don't get identified as malicious. So I guess that's my contribution to make the world a better place, coming up with types of malware that are even more dangerous than what you already have out there. But the reason why we do this is not that because we are horrible people, or at least not just because we are horrible people, but also because it's very important we understand the limits of current techniques to identify malicious software, because once we identify those techniques, the next step is then coming up with more robust techniques. So it's essential we do this before the bad guys get there. Quickly, other things I work on. One interesting project that I recently started, security of home smart devices, such as locks, cameras, thermostat, and such. With students, we're trying to design techniques that can identify security problems in your smart home network and also potentially interact with non-technically trained users to resolve the security issue and teach the users better security hygiene for their network. Also, Also, another project, this is in collaboration with the Office of Naval Research. So what the Navy cares about in their data centers and their systems is to run software which accomplish exactly what they needed to accomplish, but nothing more. So In other words, they want to be able to remove features from networking software that are unnecessary for a particular task. That's because the more stuff is in a software application, the more security problems, the more overhead and the such. So this problem involves identifying features that are not necessary for a particular task and remove them so that you don't have them there anymore. I work also on other things, and if you're interested in anything I mentioned today, I'm happy to talk more offline. Thank you very much.